In this class, now I am going to explain trigonometric ratios of compound angles. Now let us see the definition of compound angles. An algebraic sum of angles is known as compound angles. See here, suppose if you consider A is one angle, B is one angle, then whose sum A plus B is known as one compound angle. And see, A plus of minus B, this is also one compound angle because A is one angle minus B is one angle, then whose sum is known as compound angle. Suppose if you consider three angles, A plus B plus C, so this kind of angles are known as compound angles. Now I am going to define all these trigonometric ratios at these compound angles. Now first let us define sine ratio with respect to this angle. Sine of A plus B, which is equal to sine A cos B plus cos A sin B we will get. Okay, so in my previous classes I gave you the proof of this cos A plus B and sin A plus B, so from which we derived the rest of the compound angles formulas. Okay, but in this class just now I will discuss with you conceptual points related to these compound angles. So in that, the first formula is sin of A plus B, so which is equal to sin A into cos B plus cos A into sin B. So similarly, sin A minus B, how do we get sin A minus B? So just you have to write this minus B, how to express this as A plus of minus B. Now wherever B is there you write minus B and go for simplification. So finally we will get sin A into cos B minus cos A into sin B. Next, cos of A plus B, now which is equal to cos A into cos B plus sin A into sin B. So here plus here minus will come. For the cos A plus B, here in the between the angles, if it is plus is there, right side minus will come. But in the case of sines, here minus, minus, plus, plus. So right, next cos A minus B, now which is equal to cos A into cos A into cos B plus sin A into sin B. Okay, I hope you have understood these four formulas. Sin of A plus B equal to sin A into cos B plus cos A into sin B. Go to the second one, sin of A minus B equal to sin A into cos B. Here minus here minus will come, cos A into sin B. Now go to the third one, cos of A plus B equal to cos A cos B. Here plus here minus will come, sin A into sin B. Now cos of A minus B. So here cos A cos B plus sin A sin B you will get. Okay. Now let us go to the tan of A plus B. Okay. How do we get tan of A plus B? So, tan can be expressed as sin by cos. So suppose if you want tan of A plus B, so you can write sin A plus B by cos A plus B. Both expansions we have seen. Okay. So write sin A plus B by cos A plus B, and in numerator and denominator divide with cos A cos B. So finally you will get tan A plus tan B by 1 minus tan A into tan B you will get. But observe that A should not be 45 degrees and A and B both should not be 45 degrees. So here A, B both should not be 45 degrees. Because if it is 45, 45, tan 45 1, tan 45 1, 1 minus 1 0, something by 0, not defined case will come. Hence A and B simultaneously should not be 45 and also A and B should not be odd multiples of 90 here, A plus B. So should not be odd multiples of 90, 2n plus 1 into pi radians by 2, where n belongs to integer. Even A also should not be odd multiples of 90, where n belongs to z, and B also should not be odd multiples of 90. Okay students, see here tan of A plus B equal to tan A plus tan B by 1 minus tan A tan B. So when it can be okay, this is equal to this. So whenever A and B should not be 45. Okay. So because if it is 45, this becomes 1, 1 minus 1, 0, something by 0 not defined. Hence it should not be, okay, 45 degrees. These A and B both should not be equal to 45. And also, okay, alright, A plus B should not be odd multiple of 90, because at odd multiple of, see here, if it is odd multiple of 90, at which, so tan will not be defined. As you know, tan 90 is not defined. Not only at 90 but also at all odd multiples of 90. So this tan will not be defined. Similarly, A should not be 90, because tan 90 not defined. Not only at 90 but also at all odd multiples of 90. This A and B are not defined. Okay. So this is equal to this if and only if it satisfies these conditions. Similarly, tan A minus B is given. See, so tan of A minus B is equal to, here minus will come, here plus will come. But here A and B can be 45. But whose sum? See here, A and B should not be, here difference should not be odd multiple of 90. And also A should not be odd multiple of 90, B should not be odd multiple of 90. Okay, tan of A minus B equal to tan A minus tan B by 1 plus tan A tan B, where A minus B should not be odd multiple of 90 and A should not be odd multiple of 90, B should not be odd multiple of 90. Okay, right. So next let us go to the cot of A plus B. Cot A plus B can be written as cos A plus B by sin A plus B. Cos A plus B formula is there with you, sin A plus B formula is there with you. Just now I have written on the board. Okay. So later on, divide the numerator and denominator. Okay. So with cos A cos B, same however you divided with okay, tan of A plus B formula. In the same manner you divide numerator and denominator with cos A cos B. So finally, okay, no, here for this cos of A plus B you have to divide with sin A sin B, right? Cos, here this can be written as cos A plus B by sin A plus B, right? Both expansions, and divide the numerator and denominator with sin A sin B. So finally you will get this formula, cot A cot B minus 1 by cot A plus cot B, or cot B plus cot A. Okay, here also A plus B should not be equal to n pi, where n belongs to integer. Okay, A also should not be n pi, because cot n pi not defined. B should not be n pi, where n belongs to integer. Okay, cot of A plus B equal to cot A cot B minus 1 by cot A plus cot B. Similarly, suppose if you want cot of A minus B, Here plus will come, but in the down, cot B minus cot A you will get. But here A and B both should not be equal. Okay, so both should not be equal, and also okay, both should not be equal, and A should not be n pi and B should not be n pi. So A minus B should not be n pi, where n belongs to an integer. Okay, students, right. Now hereafter, so we don't have any formulas for cosecant of A plus B and secant of A plus B. If it is given, then you convert them into the sine causes and go ahead with that, okay, problem. Okay, right. Now let us go to sum of the sine A plus B plus sine A minus B. Now write both expansions and add them. Okay, so in that addition, that second terms will be get cancelled and first terms will be similar. Okay, like terms you will get. If you add the two like terms, so you will get 2 sin A into cos B. Yes, next. Sine of A plus B minus sine of A minus B. Now which is equal to? Tell me, students. 2 cos A sin B. Right, next. Cos A plus B plus cos A minus B. Now which is equal to? Yes, tell me, students. 2 cos A cos B. Cos A plus B minus cos A minus B. So minus 2 sin A into sin B. Okay, students, I hope you have understood this. Sin of A plus B plus sin of A minus B. You know both expansions, and write those two expansions and add them. Finally, you will get 2 sin A sin B, and sin A plus B minus sin A minus B, which is equal to 2 cos A sin B. Cos A plus B plus cos A minus B equal to 2 cos A cos B. Cos A plus B minus cos A minus B equal to minus 2 sin A sin B. So from these four formulas, we will get that transformations of trigonometry formulas. So in that chapter, I will explain you whose proofs. There also we will get 4 formulas. That 4 formulas will come from this okay, 4 relations only. Very, very important. Remember these 4 formulas. Right. Next, suppose if you multiply sin A plus B into sin A minus B. Sin A plus B into sin A minus B. If you multiply these two, you will get sin square A minus sin square B. Yes. Next. Okay. Sin A plus B, sin A minus B. Here also, both expansions you know, write them, and which looks like A plus B into A minus B, and go for simplification. You will get A square minus B square. So in that simplification, so RHS, if you would if you would want to see that RHS expression in terms of sines, eliminate the cos. If you want the result in terms of cos, eliminate the sine. So here, sine, in terms of sine, like this you will get sin square A minus sin square B. Sin A plus B into sin A minus B equal to sin square A minus sin square B. Suppose this result if you want in terms of cos, you know, as per the first identity of trigonometry, sin square A can be written as 1 minus cos square A, minus sin square B can be written as 1 minus cos square B. Now open this bracket, 1 minus cos square A. Here it is minus into minus plus cos square B. So plus 1 minus 1 cancel. What is left here? Cos square B minus cos square A. Cos square B minus cos square A. Sin A plus B into sin A minus B equal to sin square A minus sin square B. and cos square b minus cos square a. Okay, right. Next, yes, cos a plus b into cos a minus b. Now which is equal to cos a plus b into cos a minus b equal to, yes, cos square a minus sin square b you will get. Cos a plus b into cos a minus b equal to cos square a minus sin square b. Okay, same like however you simplified sin a plus b into sin a minus b, in the same manner you would have to simplify. Finally you will get cos square a minus sin square b. Just you remember like a standard result. So based on the standard results we will have applications. And even, okay, apply first identity of trigonometry, sin square theta plus cos square theta equal to 1. From that this can also be written as here cos square a, you can write as 1 minus sin square a. And if you express the sin square b in terms of cos s, 1 minus cos square b you will get. Now open this bracket, 1 minus sin square a, so minus 1 minus into minus plus cos square b. So plus 1 minus 1 cancel, cos square b minus sin square a. Okay, so note down this, cos square a minus cos a plus b into cos a minus b equal to cos square a minus sin square b or cos square b minus sin square a. Similarly, yes, tan a plus b into tan a minus b. So which is equal to tan square a minus tan square b by 1 minus tan square a into tan square b you will get. Okay, right. Next, suppose if you want to define sine at a compound angle a plus b plus c, so you will get this sin a into cos b cos c plus cos a into sin b into cos c plus cos a into cos b into sin c minus sin a into sin b into sin c. Okay students, so remember like a standard result. Here proofs are not required, just remember these formulas. Using these formulas we can do some applications, right? Okay, I think I hope you have understood sin of a plus b plus c equal to sin a into cos b cos c plus cos a into, here sin first, here it came to the middle, here it came to the last, here minus, plus plus plus, but for the last one minus. Similarly, cos of a plus b plus c, now which is equal to cos a cos b cos c, first you will get, next here cos a into sin b sin c, okay, minus, okay, so see here cos a cos b cos c minus cos a sin b sin c, and here first sin a into cos b sin c you will get, and in the middle, okay, so for the last one here you will get minus sin a into sin b into cos c you will get. Okay, so this is the cos of a plus b plus c formula for the first one, plus for the remaining three terms minus sign will come. Okay, hereafter tan of a plus b plus c, now which is equal to, yes, tan A plus tan B plus tan C, yes, minus tan A into tan B into tan C whole by, okay, see students, tan A plus tan B plus tan C minus tan A into tan B into tan C by 1 minus tan A into tan B minus tan B into tan C minus tan C into tan A we will get. Okay students, tan of A plus B plus C equal to tan A plus tan B plus tan C minus tan A into tan B into tan C whole by 1 minus tan A tan B minus tan B tan C minus tan C tan A. So now which is equal to, so tan A plus tan B plus tan C can be written as tan sigma tan A minus, this is the notation, okay, for these three terms, you know, and right here tan A into tan B into tan C can be denoted by pi. Pi means product here, not like irrational number, not 22 by 7. Okay, so okay, how much is this here? What is the meaning of this? It represents product tan A whole by 1. So from these three terms take minus common. So inside what do you get? Tan A tan B plus tan B tan C plus tan C tan A. Now sigma tan A into tan B. Okay, so this is tan A plus B plus C formula. Similarly, cot A plus B plus C also same like this one only. Cot A plus B plus C, which is equal to cot A plus cot B plus cot C minus C cot A into cot B into cot C. Same like previous one you will get. So 1 minus cot A cot B minus cot B cot C minus cot C cot A. This is cot of A plus B plus C formula. Okay, you know here also conditions for A, B, C. Same like cot A plus B, tan A plus B. Whichever conditions there we discussed, same conditions applicable for this tan of A plus B plus C and cot of A plus B plus C. Okay, alright students. And let us go to the tan 44 pi radians by 4, nothing but 45 plus A. Now you know tan A plus B expansion, tan 45 plus tan A. Here treat this as A, treat this as B. It looks like tan A plus B. Tan A plus B equal tan A plus tan B by 1 minus tan A tan B. 1 minus tan A tan B. Tan 45 1 plus tan A by tan 45 1 minus tan A. Okay, so now tan A 1 plus tan A. Tan A can be written as sin A by cos A whole by 1 minus tan A can be written as sin A by cos A. Right, when you take cross multiplication, what you people will get, tell me? When you take cross multiplication, what do you get? Cos A plus sin A by cos A whole by cos A minus sin A by cos A. Cos A cancel. Okay, tan 45 plus A can be written as 1 plus tan A by 1 minus tan A, and even in some applications, so in the place of cos A plus sin A by cos A minus sin A, we write directly this. So I think, I hope you have understood why this is equivalent to this. Okay, please note down this. Here you know A should not be 45 degrees. Next, similarly, if it is minus is given, same like previous one. So tan A means tan 45. That is going to be 1 minus tan B. A. Okay, treat this as A, treat this B as B. Now it looks like tan of A minus B, which is equal to tan 45 1 minus tan B, tan A by 1 plus tan A. Okay, 1 minus tan A can be written as sin A by cos A. 1 plus tan A can be written as sin A by cos A. Now take cross multiplication. Cos A minus sin A whole by cos A. So here cos A plus sin A by cos A. Cos A cancel. Okay, tan 45 minus A, which is equal to 1 minus tan A by 1 plus tan A, and cos A minus sin A by cos A plus sin A. Okay, right. Hereafter, okay, so suppose if you want to use product tan 45 plus A into tan 45 minus A. Now which is equal to tan 45 plus A? 1 plus tan A by 1 minus tan A. So this is 1 minus tan A by 1 plus tan A. Okay, now both are cancelled. Both are cancelled. Now result will be 1. Next, cot A 45 plus A. Now expand it. It looks like cot A plus B, no? Cot 45 into cot A minus 1 by cot A plus cot B. You know cot 45 is 1. Now cot A minus 1 by, so here cot 45 1. Cot A plus 1 you will get. Hereafter express cot A as cos A by sin A. This is also cos A by sin A. Now take cross multiplication. Cos A by sin A plus 1. Okay, now take cross multiplication and go for simplification. When you take cross multiplication, here you will get cos A minus sin A by cos A whole sin A. Right here cos A plus sin A by sin A. Sin A cancel. Now what is left? Cos A minus sin A by cos A plus sin A. Cot of 45 plus A can be written as cot A minus 1 by cot A plus 1, and this is also equivalent to cos A minus sin A by cos A plus sin A. Yes. Now let us go to the cot 45 minus A. Now which is equal to cot 45 into cot A plus 1 by cot B. Cot B means here A. First will come cot A minus cot 45 you will get. The numerator plus here cot B minus cot A. This is A, this is B. Observe that. Simplify. Cot 45 is equal to 1. So you will get cot A plus 1 by cot A minus 1. Right. Now express them in cos by sine and go for simplification. Finally you will get cos A plus sin A by cos A minus sin A. Right. Now next step, same like previous one. So if you multiply cot of 45 plus A into cot of 45 minus A, your product will be 1. cot 45 plus a, cot 45 minus a. Write both expansions and go for simplification. Finally you will get 1. Right students, next. So in this chapter we have some standard angles also. So define this trigonometric ratios at an angle 15 degrees, okay, and 75 degrees. So if this question is given, so how do you answer? Like sine of 15 degrees. In my previous class I explained you this all trigonometric basic trigonometric ratios at some standard angles like 18 multiples like 18, 36, 54, 72, and 15 multiples like 15, 75, and also 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. So in my previous class that proofs are there. So you can, if you want those proofs, if you want those values, you can go through the class video. Okay students. So now here I don't want to teach you the sine 15 degrees value. Actually it is root 3 minus 1 by 2 root 2 you will get, and a cos 15 degrees root 3 plus 1 by 2 root 2. And suppose if you want a tan 15, so sine by cos, and go for simplification, 2 minus root 3 you will get. You know, sine 15 degrees also equivalent to cos 75 degrees, and a cos 15 degrees also equivalent to sine 75, and tan 15 you got 2 minus root 3, no, so that is equivalent to cot 75, and tan 15 already 2 minus root 3, no. And suppose if you want cot 15, you will get 2 plus root 3, okay, that is equivalent to tan 75. So all these proofs I have given in my previous classes. Please go through. So from there, okay. Now let us see one or two applications from these compound angles. Right. See here, if A plus B is equal to 45 degrees or 225 degrees. 225 can be written as pi radius by 4. Okay. If A plus B equal 45 or 225 degrees, then find 1 plus tan A into 1 plus tan B. If this kind of questions are given, so first what you people have to do? Sometimes they may ask you 1 plus tan A into 1 plus tan B, otherwise 1 plus cot A into 1 plus cot B. If this kind of questions are given, what you people have to do? Now multiply this one with these two. 1 into these two. 1 into 1 plus tan B. Plus tan A into these two. Tan A into 1 tan A plus tan A into tan B. Tan A into tan B. Okay now students, 1 plus tan A into 1 plus tan B equal to, so take the product of these two, you will get this. Okay, right. Now keep it aside. Now take this A plus B equal to 45 degrees. Now apply tan on both sides. Tan of A plus B is equal to tan 45 degrees. Now tan A plus B is equal to tan A plus tan B by 1 minus tan A into tan B, which is equal to tan 45 value 1. Okay, now take cross multiplication. So if you take cross multiplication, so you will get tan A plus tan B, so which is equal to 1 minus tan A into tan B. So bring it to the left side. Tan A plus tan B. When it comes to the left side, you will get tan A into tan B, now which is equal to 1. Okay. So now hereafter, in place of this, see here, write this 1. If you write there 1, 1 plus 1 is equal to 2 you will get. I hope you have understood. If a plus b equal to 45, then what is the value of 1 plus tan a into 1 plus tan b means take the product of these two, you get this. And hereafter, okay, so for this apply tan on both sides. So you will get tan a plus tan b plus tan a tan b equal to 1. So in place of this, write there 1. 1 plus 1, 2. 2 is the required result. Okay, right. Okay students, so in my next class, from this trigonometric ratios of compound angles, so I will concentrate on applications. So this class here itself I want to close. Thank you one and all.